All right. So let's go ahead. Let's go ahead and start with number 2. So the first thing I'm going to do, I'm sorry it's so loud, but they're mowing the grass right now. First thing I'm going to do is switch the order of this so it matches my sheet. And everyone should have their packets in front of them, right? You should have this in front of you so that you can refer to it. And they want us to find the vertex, the focus, the directrix, also find the points that define the latus rectum, the length, and the axis of symmetry. All right, so the vertex here is kind of like finding the center of a circle or an ellipse. So what's the vertex for this one? -1, 1. Thank you. So left 1, up 1. Is this parabola going to open left, right, up, or down? Yeah, so it's an x squared problem, so that means it's up or down. This is a positive 2, so that means it's going to open up. This is an x squared problem, so it's going to open up or down. The number in front of the parentheses is positive, so it opens up. All right. What is the p-value for this problem? So 4p equals 2, which means that p equals 1/2, 2/4, or 1/2. Okay. So from here, we're going to go up 1/2 and put a dot because it opens up. And we're going to go down 1/2 and put a line because the directrix always goes underneath the parabola. So up 1/2, put a dot, down 1/2, put a line. Okay, so that part where we went up 1/2 and put a dot, what's the name of that point? The focus. So if the vertex is -1, +1, then the focus is -1, 1 and 1/2. And the directrix is a horizontal line. How do we write the equation of a horizontal line? Y equals, and what number is it going to be? 1/2. So from 1, the vertex was at a y coordinate of 1. We went up 1/2 for the focus and down 1/2 for the directrix. Okay. And then from there, we take the point of the focus and we go a length of 2p to the right and 2p to the left. So p is a value of 1/2. So what is 2p? 1. So I'm going to go to the right 1 and to the left 1. And those points that I just drew are called what? The endpoints of the LR, the endpoints of the latus rectum. All right, so endpoints of LR. So these moved over from the focus. So I'm going to look at the focus, and they moved left and right a length of 1. So the endpoints of the latus rectum, if I went left 1, that's -2, 1 and 1/2. If I went right 1, that's 0, 1 and 1/2. And now that I have 3 points, that's enough to draw a parabola. So we found the vertex, the focus, the directrix. We found the points that define the latus rectum. We have to find the length. If we went left 1 and right 1 to find the endpoints, then what's the length? 2, length of 2. And you can also see the length of the lattice rectum in the equation. It's the number that's in front of the parentheses. So the 2 right there, that's the length of the lattice rectum. Okay, and then one last thing we have to find is the axis of symmetry. And the axis of symmetry is a vertical line. It cuts right through the vertex. So the axis of symmetry is a vertical line, so that's an x equals equation. X equals -1. Good. So those are all the things we're going to be finding. And again, they're all written on your packet, right? So you just have to be able to read the diagram. So that p-value is very important because it helps us find everything, right? The vertex we can get from the equation. The p-value tells us how far to go up and down to find the focus and the directrix. From the focus, it tells us how far to go each direction to find those endpoints for the lattice rectum. So we need that p-value. It's super important. Okay, shall we try another one? Yeah.
When we draw these, if we draw them wrong, they're really points out.
If you draw them wrong?
Not like completely wrong, but if they're like scaled wrong.
If it's wrong, you'll get points taken off. Yes. If you are trying to draw 0.5 and you draw 0.6, I'm not going to mark you out. If your points are like just a little bit off. Yeah. All right. Let's look at number 4. So again, we're going to go ahead and switch the order so it matches our resource sheet. Can anyone tell which direction this one goes? It goes down, yeah. So it's an x squared, which means up or down. That's negative, so that tells us that it goes down. What's the vertex? -5, +2. Okay. So we have 4p equals -2. And so what is the p-value? Yeah, -1/2. Here, we don't really need to think about positive versus negative because we know we're just going distances, so you can just say p is 1/2. So what are we going to do to find the rest of the information? This graph is opening down. The p-value is 1/2. We're going to go down 1/2, and what did we just find? The focus. Okay, so here's the vertex. We go down 1/2. There's the focus. So I'm going to go ahead and say the focus is x coordinate stayed the same. What's the y coordinate? One and 1/2. Okay. And then what else do we do? The directrix goes up 1/2 and make a line. So the directrix is a horizontal line, y equals 2.5. Okay. So we have the vertex, we have the focus, we have the directrix. What are we going to do next? The endpoints of the LR. How do we do that? Go over 2p. So p is 1/2. So if we go over 2p, go over 1. So we're going to go left 1 and we're going to go right 1. And that's enough information for us to draw our U shape for the parabola. So from the focus, if we go left 1 and right 1, what are the points going to be? What's the length of the lattice rectum? Yeah, and when we talk about lengths, do we typically say negative? No, so what are we going to say instead of negative 2? Just 2. Yeah, 2 boxes, it's got a length of 2. What else do we have to find? Okay, axis of symmetry is a vertical line that's x equals -5. Yeah, it goes right there through the vertex. X equals -5. All right. How are you guys feeling about that? Okay? All right, let's do number 5, and then I'll let you guys work on your own for a bit. So number 5, also written in the wrong order. So I'm going to go ahead and switch it around. Y squared equals negative of x plus 3. And this y squared right here, I'm just going to call y plus 0 squared. So it looks a little bit closer to my sheet. Makes me feel a little bit better when I see that. Can anyone tell which direction this one opens? Not down. Left. How come this one's left and not down? It's a y squared problem. Yeah. Okay. So I'm going to circle this. I'm going to say this one opens to the left. So we got to be careful this time. Our vertex is not 0, -3. Do not write that. What is our vertex? -3, 0. So we have to be careful. The x parentheses go with the x coordinate. The y parentheses go with the y coordinate. So whenever you have a parabola that opens left and right, it's going to feel backwards. Okay, so -3, 0. Let's go ahead and put a point there for our vertex. And then we have 4p equals -1. Yeah, so p equals -1/4, or you can just think positive 1/4 since the sign doesn't really matter. So this picture opens to the left. This parabola opens to the left. So what are we going to do next? Not up or down. We're going to go left and right. So I'm going to go left 1/4, and am I putting a dot or am I putting a line? A dot. So I'm going left 1/4 and putting a dot. I know the fractions are going to be hard to do because they're so small. And then we're going to go right 1/4 and put a line. So here's our directrix. So if you were at -3, 0 and you went to the left 1/4, what do you have? -3 and 1/4, comma 0. The directrix is a vertical line, so that's an x equals equation. So you were at -3 and you went to the right 1/4. -2 and 3/4. Okay. How are we going to draw the rest of the parabola? Very carefully. It's very small, right? We're going to go up and down a value of 2p. If p is 1/4, then what's 2p? 1/2. So we're going to go from the focus, we're going to go up half a box and down half a box. And we have a super itty-bitty parabola that's opening to the left. And then we have to think about how to write those points. So we started at the focus. The x-coordinate is going to stay the same, but we went up 1/2 and down 1/2. So I'm keeping my x-coordinate. What should I write for up 1/2 and down 1/2? So positive 1/2 for up 1/2, negative 1/2 for down 1/2. All right. Oh, we've got some more stuff to find. What's the length? -1, or we're not going to say negative, right? We're just going to say 1. And then axis of symmetry this time is horizontal, so that's a y equals equation. And it's going to be y equals 0, which is the x-axis, right? Okay. All right. I'm going to let you skip number 1. Why is it nice of me to let you skip number 1? Because that's a 1/2, and when you divide that by 4, that's going to be real tiny. So let's skip number 1, because that's going to be super obnoxious to draw. Number 3 is not bad. Number 6 is okay. We've already done one of those. So I'll go ahead and let you guys work for a little bit, and then after that, we can start looking at some of these other types of questions. Sound good? Yeah. X equals because it was a vertical line. Yeah. So if we look at, and that might be good, let's add that to our notes. So here's our picture, right? So our directrix here would be y equals something, because that's a horizontal line. And for this one, our axis of symmetry would be an x equals equation. And then when we switch to the other picture, the directrix would be an x equals equation, and the axis of symmetry would be a y equals equation, because it's horizontal. Was there anything else that came up that we should add to our picture? No? Okay. So go ahead and work on that for a bit. So, shall we just start at the beginning? Yeah. So let's go ahead and let's maybe write this as a mixed fraction instead. So here's what we're going to do. Go ahead and hit alpha y equals, and number 1, and we're going to type in 59/12. And actually, I can't really turn it into a mixed fraction that way. Okay, we're going to do 59 divided by 12. That's 4. See that? 4.9. So I know that this point is going to be 0, 4, 4 in some fraction. So what I'm going to do is I'm going to minus the 4 off, just so I have that decimal. I'm going to turn that back into a fraction. 4 and 11/12. Anyone know why I rewrote it like that? Yeah, now I know how much I went from 5 a little bit more easily. You guys see that? So if it's, this is, let's go ahead and graph, do a little sketch. So 0, 5. And then should the focus be above the vertex or should it be beneath the vertex? Beneath it, right? Just a little bit, just barely beneath it. Okay, so what direction does our parabola open? Down. Okay, so if we grab our packet and we start writing information down, we're going to have x something squared equals something with a p, right? Y something. Right? Okay. What number is going to go with the x? 0. So we can put plus 0 or minus 0, or you cannot write parentheses at all and just put plain x squared. What should I put with the y? -5. So we're going to put -5 because we're doing the opposite sign. And then inside, since this is going down, I know that this value is going to be negative, right? And I have to do 4 times p, and what is my p value? So the vertex is at 5, the focus is at 4 and 11/12. So how far down did it go? 1/12. It went down 1/12. So in my calculator, I'm going to do 4 times 1/12. That's 1/3, right? So I'm going to say if P is 1/12, then 4P is 4 times 1/12, which is 1/3, right? And so this is going to be negative 1/3, and again I have the negative because I know that this graph is upside down. Okay. Let's try the same thing on number 8. So our vertex is 4, 1, our directrix is 5/4. So 5 divided by 4 is 1.25. So I'm going to subtract off the whole number. And I'm going to take the decimal and turn it into a fraction. So that's 1 1/4. And then I'm going to go ahead and draw a sketch. So right 4 up 1. 1 1/4 is where our directrix is, so that's going to be a little bit higher than 1. So which direction does our parabola open? Down. So that means that if we look at our packet, we're going to have an x squared, a number, and then a y. Say it again. X minus 4, y minus 1. What's the p value? 1/4, yep, because it went from a y coordinate of 1 to y equals 1 1/4. So the p value is 1/4. That means that 4 times p is 4 times 1/4. That equals 1. And so is this value here going to be a positive 1 or a negative 1? Negative 1 because this graph is upside down. All right. Let's go ahead and draw this one. So they said the focus is left 1/16 and up 8. The directrix is a vertical line of positive 1/16. So I'm going to go to the right 1/16 and draw a vertical line. So which way does this parabola open? Left. So there's my focus, negative 1/16, positive 8. There's my directrix, a vertical line at 1/16. It opens to the left, so that means we have a y equals equation. Now the vertex is right smack dab in the middle of the focus and the directrix, right? So the focus is at negative 1/16, the directrix is at positive 1/16. So what is the vertex going to be at? 0, right in the middle. So the vertex has an x coordinate of 0. What's the y coordinate of the vertex? 8. Yep, it's right up there at the same spot as the focus, so it has a y coordinate of 8. Okay? So how do we put that in our parentheses? Y minus 8, yep. And then the x you can put plus 0, or you can put minus 0, or you can just put a plain x by itself. Whatever you want to do with that is fine. What's the p value? 1/16? P value is 1/16. So then what do we do? So 4p is 4 times 1/16, which is 1/4. So I'm going to put a 1/4 here. Is the 1/4 supposed to be positive or negative? Negative, because it opens to the left. So have you guys noticed we've basically done the same process 3 times, even though they were all different? What's our process? Okay. We have to find a p-value, right? P-value is important. What else is important? The vertex. The vertex helps you figure out what numbers goes in the parentheses. What else is important? Yeah, if it opens left, right, up, down, because that tells you which equation to use, right? Okay. So look at number 10. They're already telling you that it opens up or down, right? So that means that we already know how to start this equation. We're going to start by saying x something squared y they gave us the vertex. So x plus 2, y plus 3. Okay. So if I draw a picture of this, left 2, down 3, that's the vertex. And then we have the point 1, 3. Does this graph go up or down? This is the vertex. Has to go up. Okay. All right, so that means, now did they give us anything? Did they mention the lattice rectum? Did they mention a focus? So this value they gave us has nothing to do with P. Nothing, okay? So what I'm going to do is I'm going to put a P in there. I'm going to say positive 4P. I'm saying that it's positive because once I drew a sketch, I knew that my parabola had to go up. It could not go down, okay? Now I'm going to go ahead and plug in 1 for x and 3 for y. And I'm going to do that because I know that's a point that shows up on the line. And if I plug in something for x and y, then the only thing I have left is p, and I can solve for that. Okay? So I'm going to say 1 plus 3, nope, 1 plus 2. 1 plus 2 is 3. 1 plus 2 squared equals 4p times 3 plus 3. So 3 squared equals 9 equals 4p times 6. What's 4 times 6? 24. And we can divide by 24. So p equals 9/24. We don't really care what p equals though, right? What do we actually want? 4p. So p equals 9/24. 4p equals 9/24 times 4. Three halves? All right, so I'm going to go right back up here and write this down. I have x plus 2 squared equals 3 halves y plus 3. Okay, I'm going to go ahead and let you guys keep working on that. All right, we're gonna go ahead. We're gonna go ahead and do number 13. This is one, you just have to make it look like your packet. So go ahead and grab your packet. I can see that there's a y squared in the equation, so I know I'm making it look like this, right? So I want to keep the y's on the left side. I want to move everything else to the right side. So I'm going to leave negative y squared. I'm going to leave positive 4y. I'm going to move the x. I'm going to move the 10. All right, now if you look at your packet, should we have a negative over here? Probably not, right? We probably don't want a negative in front of that y squared. So I'm just going to take the entire problem and I'm going to multiply by -1. And I can do that because I'm doing it to literally everything. So it's going to keep things balanced because I'm doing it to all the stuff. So I've got y squared minus 4y. I'm going to leave some space because I'm going to complete the square in a second. Equals positive x minus 10. Okay. So now I have to complete the square over here because I want this to look like y minus a number squared. So how do I complete the square? Divided by 2. So -4 divided by 2 is -2. -2 squared is 4. So I have to add 4 to the left side of the equation. And then I also have to add 4 to the right side of the equation to keep everything balanced. So now I've got something squared equals the other side. So what goes in my parentheses? Y minus 2, so I always put whatever I got when I divided in half. Y minus 2. And then on the right side I have x minus 6, okay? And then if I look at my paper, it says I need to have parentheses here, and I need the parentheses to be there so that the x is all by itself. And I can already see that the x is all by itself. I don't have a coefficient that I need to factor out. So I'm just going to put parentheses right here, and then I'll go ahead and put a 1 right there just so that it kind of matches my paper, and so that I know that the 4p value would have equaled positive 1. You're not wrong if you don't put the parentheses, but it's kind of nice to have it really match up. All right, so the best thing you can do to finish out these problems is make sure any ones that you're getting stuck on, just that you draw a picture of them. I think I'm going to ask you guys to go up through number 15. So get through number 15, then you can stop. We'll probably do some more parabola questions as a warm-up tomorrow. All right, so through number 15.